So here we have to divide one radical expression by the other. Now clearly we could cancel the numbers, common factors. So if you have a 2 in the numerator and 2 times 6 equals 12 in the denominator, clearly the 2's cancel. Now we could combine these two terms, the radical expressions. So if I have a cube root of a over the cube root of b, that could be written as the cube root of a over b. So that's what I'm going to do. I'm going to write it as the cube root of 18 from the numerator divided by 9 from the denominator. Since both of them are cube roots, I'm able to combine them. So 9 times 2 is 18. I cancel common factors and I get 1/6. The 6 is in the denominator. 2 over 2 is a 1. 1/6 the cube root of 2. That is the simplest form. So that's our first problem. The second one, something very similar. If there's a common factor in the numerator and the denominator, we could cancel those two. So we can cancel the 2's. 4 is 2 times 2 and 10 is 2 times 5. Now I'm going to combine the two cube roots and write it as the number in the numerator divided by the number in the denominator. Now this is 2 over 5 times the cube root of 6 times 7 is 42. 7 times 6 is 42, and I'm left with 2/5 times the cube root of 7. Notice that in both cases the cube roots are in the numerator. Couple of problems here. 11 over 2, and we have a square root in the numerator and a square root in the denominator that can be combined. So let's keep the 11 over 2. So that is these two numbers, nothing cancels. But we could combine the two numbers, one in the numerator, one in the denominator, by writing it as the square root of 40ab cubed over 5ab. So let's simplify what's inside, and that is 11 over 2. If anything cancels, we're going to cancel that. 4 goes, so that's 5 goes 8 times into 40. 5 8s are 40. The a's cancel, and b cubed over b to the 1 is b cubed, b to the 3 minus 1. So one of the b's gets cancelled, the 5 gets cancelled, and this is b to the 3 minus 1 because that's a 1. This is equal to 11 over 2. 8 can be written as 2 squared times 2 to the 1, and this is b squared. And the reason I'm splitting the 2 cubed as 2 squared times 2 to the 1 is because now I'm going to break it down and simplify. Square root of 2 squared, square root of 2, square root of b squared. The square root and the square cancel each other out, and we have 11 over 2, 2 radical 2, 2 times radical 2 times b. So we cancel the 2's and we get 11b radical 2. So when you see terms inside the radical sign, make sure you simplify it completely. Now let's look at the next one. So I have 3 over 4x. I'm going to leave that alone for a minute. I can combine the radical expressions in the numerator and denominator. So I have 120 x squared y cubed over 6y. Now this is equal to 3 over 4x. Square root of 120 divided by 6. 6 times 2 is 12. 0. So that is 6 times 20 is 120. And then I have an x squared and then a y cubed in the numerator, but there's a y in the denominator, which is y to the 1. So I subtract 1. That's the rule of exponents. So 3 over 4x. So this is over 6. Cancel the 6's. And I have 5 times 4 equals 20. 4 is 2 squared. Times 5 is 20. And I have x squared, y squared. So now I'm going to take the square root of 2 squared times the square root of 5 times the square root of x squared times the square root of y squared. So the square root and the square cancel each other out. So it's 3 over 4x times 2 radical 5. Square root and x squared cancel each other out. So I have an x, square root and y squared cancel each other out, and I have a y. Combining all the terms and cancelling whatever I can, I get 3 times 2 is 6 y from here, radical 5 over 4. I should have cancelled the 2. So this is 3 times 2 and this is 2 times 2. So we can cancel the 2's and we get 3y radical 5 over 2. 3y radical 5 over 2. So in math, we never leave a radical expression in the denominator. So how do we deal with this? We have a radical expression in the denominator, and the idea is that we need to get rid of it. You can never write your final answer with a radical expression in the denominator, and that's the norm. So basically, how do we get rid of it? Now, this is how you have to be thinking. What do I multiply radical 2 with in order to make it a number that is not a radical expression, which means you would get rid of the radical sign. So what I'm going to do in the first problem is multiply radical 2 with radical 2, but then I can't just multiply the denominator with the radical 2. I have to do the exact same thing in the numerator. So I have 3 radical 2 over radical 2 squared. So radical 2 times radical 2 is radical 2 times 2, which is 2 squared. The square cancels with the radical sign, and I have 3 radical 2 over 2. So this is equal to 3 over radical 2. However, it's just written in a way that the denominator is not a radical expression. So what we multiply the numerator and denominator with is a radical 2, and that's called the rationalizing factor. Let's look at the second problem. So the second problem again has a radical expression in the denominator. So let's just simplify this. Radical 1 over 5 is radical 1 over radical 5. What we do is think about what is it that I can multiply with radical 5 to make it a number without a radical sign. So multiplying radical 5 with radical 5 in the denominator gives me radical 5 the whole squared. And the square and the radical sign cancel each other out, and we get a 5. And in the numerator, radical 1 is a 1, and then of course we multiplied it with radical 5. So your answer is radical 5 over 5. But the first step was to simplify this expression. Now again, we have a radical expression in the denominator. So let's see what it looks like. It's the cube root of 3 squared. Now if, and here we are doing some wishful thinking, if I had a cube root of 3 cubed, then the cube root and the cube would cancel and we would be left without a radical sign, and that's the goal. So what I need is the cube root of 3 to the 1, and you'll see why. We multiply the numerator and denominator with the cube root of 3 to the 1. So I have 2 times the cube root of 3 over, we're going to combine these two, and that's going to give me 3 squared times 3 to the 1, and that was the whole point. I needed a 3 cubed inside. So 2 cube root of 3 over the cube root of 3 squared times 3, that is 3 cubed. Cube root of 3 cubed. So cube root is 1/3, 3 cubed is to the third, the 3 and the 3 cancel, and you're left with the 3 in the denominator and the cube root of 3 multiplied in the numerator. So the whole point of multiplying with a rationalizing factor is to get rid of the radical sign in the denominator. Now let's look at the next one. So we have 3 over the cube root of 4, and that's equal to 3 over the cube root of 2 squared. Now if I could just multiply the 2 squared with the 2, I would get a 2 cubed, and the cube root of 2 cubed is just 2. So what do I multiply with to make it a 2 cubed? I already have a 2 squared in there. I need to get another 2 to make it a 2 cubed, which means I multiply the denominator with that, and I also multiply the numerator with the cube root of 2 to the 1. So the numerator, I have 3 cube root of 2 to the 1 over, I'm going to combine these two to get the cube root of 2 squared times 2 to the 1, that is 3 cube root of 2 over the cube root of 2 cubed. The cube root and the cube cancel each other out. So 2 cubed to the 1/3, that is the cube root of 3, is 2. So my final answer is 3 times the cube root of 2 over 2.